doing well. My name is Shriya Bansal and I'm currently working as a software engineer at Microsoft, and I'm also an educator at Relevel. So in this video, we did touch upon, in the previous video, we did touch upon the idea that there are different system components that are available that the operating system basically manages, right? So there are a lot of management tasks available. So, and in these future modules, we are going to take a deep dive, right, and talk about in great detail about all of these management tasks. Okay, out of which the first one that we have is process management. Okay, then we have main memory management, then we have file management, input output system management, secondary management, networking, protection system, and command interpreter system. Okay, so these are all the systems that are available to us. Let's take a look at all of them one by one. So basically, when we think of a process, like I told earlier also, a process is nothing but a program in execution. So whenever you create a program, which is nothing but a set of instructions, it's usually present in the secondary memory. But when you take that program and you load it into the main memory for execution, it gets converted into a process. Now, a process definitely needs resources, CPU time, memory, files, input-output devices in order to accomplish the task that it has been assigned to do. Now, the operating system is basically responsible for the following activities in connection with the process management. Firstly, it's responsible for process creation and deletion. Secondly, it's responsible for process suspension and the resumption of the process again, right? So it will take care of the creation of a process, and after that, it will take care of the deletion of the process as well. After that, it is responsible for process suspension. That means if you want to terminate or suspend a process in between, and then we want to resume that process. And then it is also responsible for process synchronization. Process synchronization means that when we have so many processes available, right, all of them should be synchronized with each other in order to provide the final desired output, right? In order to make sure that no process blocks each other and the final output is desirably received. For that, we have process synchronization mechanisms available. And apart from that, we also have process communication. If there are different processes, we need suitable mechanisms so that the processes can communicate with each other in order to drive out the entire task. So the process management basically includes all of these tasks, and operating system is responsible for managing the process management. Okay, that was the first task. The second one is main memory management. So what we know is memory is nothing but a very large array of words or bytes, right? Where each has its own address. Now it is a repository. Main memory is basically a repository of quickly accessible data. So we know that in terms of memory, we have primary memory, secondary memory, right? Main memory includes primary memory, which is smaller in size, but it's very quick, or it's very efficient to access data present in the main memory. So it is basically a repository, or I can say a collection of quickly accessible data that is shared by the CPU and the input-output devices. Okay, and main memory is a volatile storage device. Okay, what do you mean by volatile storage device? It means that as soon as you restart your computer, the information present in the main memory is lost. Okay, or in other words, we can say that its contents is basically lost in case of a system failure or the moment you restart your system. So the operating system is responsible for the following activities related to the main memory management, which are: first, it needs to keep a track of which parts of memory are currently being used and by whom. Okay. It also needs to decide which processes to load in memory when the space actually becomes available. So you take processes from the secondary memory, you load it in the primary memory, main memory. And when those processes are executed, even the main memory becomes empty. So the main memory has space, and then you need to pick processes again and put it into main memory. So which processes will be picked? That is handled by the operating system, right? And it also keeps track of the fact that if you have a certain space of memory, how much of what is being used by whom. Okay, and it also sometimes allocates and deallocates the memory space as and when required. Okay, so that's what main memory management is. Next, we have file management. So file, is nothing but a collection of related information, right? A file is a collection of related information which is defined by its creator, okay? Commonly, files represent programs and data. Okay, files could be a collection of related information which is defined by its creator. And commonly, files have programs and data inside it. Now, the operating system is responsible for the following activities related to file management. So, operating system takes care of the creation and the deletion of file. It takes care of the creation of directory. The file and directories, not only just creation and deletion. It also takes care of the fact or how do we map those files onto the secondary storage, and how do we provide a stable backup for these file in terms of non-volatile storage media. So all of these management tasks related to files are being taken care by the operating system. Similarly, earlier, all of the management tasks related to the main memory are taken care by the operating system, and also the first one was that all the tasks related to the processes, right, is taken care by the operating system. That's the third one. The next one that we have is input-output system management. So in the input-output system management, it basically consists of a buffer caching system, okay, where you have some, there are some requests which are very frequently used, so you cache those requests, right? So that's like a buffer caching system in a very high level. Then we have a device driver interface. Like I told you, whatever input-output devices you have, you usually have a device drivers for that in order to be able to interact with those devices. So operating systems takes care of the interface of those device drivers as well. And apart from that, it also includes drivers for very specific hardware devices as well. Okay, so in terms of input-output system management, it includes everything related to device drivers and specific hardware devices. Okay. Next, we have the secondary storage. So primary storage is what we talked about, the main memory and RAM and ROM. When we talk about secondary storage, right, since primary memory is volatile and it can lose information as soon as there's a system failure, we need some other place which is big enough, because primary memory is small, main memory is small. So we need a space which is big enough and which is also ineffective to system failures as well, right? So we need some place which is big enough to accommodate all our data, and it can store all our programs permanently as well. And that's when the concept of secondary storage management kicks in. Okay, the computer system basically provides secondary storage to back up the main memory. Okay, most modern computer these days uses disks, okay, as the principal's online storage medium, okay, for both program and data. Okay, so what happens is in the modern computer systems, we are usually using hard disk and drives, which we will actually talk about in detail later, as the principal or the primary storage medium for both storing the programs and the data. Okay, and the operating system is responsible for the following activities in relation to the disk management. First of all is it needs to free space management. That means it needs to free up the space as and when it's available. It needs to make sure that the allocation of this memory in secondary storage is done well. And also whenever you have so many tasks, you need to take care of the scheduling, disk scheduling as well, where we will actually in future talk about a lot of disk scheduling algorithms also, which are very effective for our use. So that's what secondary storage management is. Then we have the concept of networking. So what happens is in a distributed system, it is basically a collection of processors that do not share memory or a clock. Okay, so what happens is a distributed system is something that is a collection of processors, okay, and that those processors do not share memory or any kind of a common clock as well. Each processor has its own local memory. Okay, now the processors in the system are basically usually connected through a communication network. Okay, and the communication actually takes place through that communication network using a protocol. So if multiple processors needs to interact with one another, they need to make sure that it happens during the using the protocol through the communication network. And a distributed system, like where the system is entirely distributed across multiple geographical location, it basically provides user access to various of these systems resources. Okay, so when we talk about access to resources, it allows computation speed up, increased data availability, enhanced reliability. Okay, so that's what all about networking is. Okay, creating a network of distributed systems among which the processors are allowed to stay connected through a communication network. So that's also one of the key things that the operating systems take care of. Next we have is a protection system. So a protection system basically refers to a mechanism for controlling the access by the programs, processes or users to both system and user resources. Sometimes it may happen that some programs and processes do not have the access to a certain resource. So you need to have a right protection system put into place that can take care of all these things, that no process or program can gain access of the resources which they are not really supposed to get. It could be a system resource and it could be a user resource as well. Okay, so that is why the protection system basically takes care of distinguishing between what is an authorized usage of a resource and what's an unauthorized usage. It also basically specifies the controls, right, and the rules that needs to be imposed, and also provides a means so that all of these rules, protocols and controls can actually be imposed. Okay, so that is what protection system is. An operating system does take care of this part. Okay, and now next we have is the command interpreter system. Okay, so what happens is there are many commands that are given to the operating system by the control statements which we deal with. Okay, there are many commands which can help to create processes and the management of resource processes. There are commands for input output handling. There are commands for secondary storage management. There are commands for main memory management, file system access, protection, networking, right, where we are dealing with the control statements. Command line interpreter, shell, right? Shell is like we talked about earlier, is a way of how we execute, right, the particular commands which are given to the operating system. So there are many commands that are given to the operating system, and that commands are executed for different management tasks that we have. So operating system needs to take care of that the interpreter system does handle all of these control statements. Okay, and this concludes our discussion for talking about all the, I would say, management tasks or the system components that are present that the operating system needs to take off. When we talk about process management, it is related to creation, deletion, management of processes. When we talk about main memory management, it's about the allocation of like the processes to the main memory, clearing up of space, adding processes from programs from secondary memory to main memory. When we talk about file management, it's about, you know, how do we create file, delete file, do manipulations on top of files, right? How do we provide access to all those files? That comes under file management. And when we talk about input and output system management, it's usually about device drivers, right? How do we tackle the device drivers? Then we have secondary management, which basically takes care of disk scheduling, right? How do we basically do free space management? How do we allocate processes? And how do we allocate storage in secondary management? When we talk about networking, we mostly deal with the idea of how different processes can communicate with each other using a communication network and with required, I would say, protocols set into place. And protection system takes care of the fact that if there is a process, right, which is not allowed the access to a certain system or a user resource, we do take care and we do have certain mechanisms for that. So we have certain rules defined of how do we identify authorized and unauthorized usage, and we have certain rules and regulations put into rules for that, and we have particular means of enforcement for those rules as well. Okay. And then we have the concept of command interpreter system, which simply means that you have a lot of commands related to above management tasks, and you need to make sure that there is a relevant system put into place which can execute all the commands relevant to the particular management task related to operating system. So this concludes our discussion about different system components which are present at a part of operating system and the management tasks that the operating system needs to take care of. In the next video, now we are going to talk about the different services that the operating system basically provides. All right. So stay tuned for that video as well, and I will definitely meet you in the next one. Bye.